To continue with the spherical mirrors, now we go to images formed by a concave mirror. Okay, we have to do it separately for concave and convex mirror because it's not easy to draw both at the same time. And here we will learn 6 different positions of object where we can get the images at different positions with different characteristics. Okay, the very first position of object is when the object is at infinity. Infinity means large distance, which means the object is far away from us, that usually we cannot see the object anymore. And when we cannot see the object anymore, we usually take incident rays to be parallel. Okay, so here you'll see 2 incident rays which are parallel to one another and also parallel to the principal axis. All right, remember the second convenient ray states when we have an incident ray parallel to the principal axis, after reflection the rays will pass through focus. So both are parallel to the principal axis, so both the rays will converge to focus. Okay, now when the reflected rays are converging at a focus, this is the point where we are getting the image. Okay, or sometimes the rays may be parallel to each other, but they may not be parallel to the principal axis. So in this case, what we do is we take the ray which is passing through center of curvature. We know this ray will retrace its path. And then we take another ray which will pass or which will be incident at the pole. Okay, so in this case, angle of incidence will be between incident ray and the principal axis. Then because we know angle of incidence is equal to angle of reflection, so we measure this. Then we measure this angle as well. Then we get the reflected ray. The point of intersection of these 2 rays will be the point where we will be getting the image, and this image will also come at focus. So now we will interpret about the image. Okay, so here is the image, here is the image. All right, where is the position of the image? It's at focus, so the first point is position. Where is the image formed? At focus. All right, the nature, it's real and inverted. Okay, in this case we can make out it is inverted, but we have a problem here. We do not see the object. So how do we know we get the real image? If the first option, seeing of an image, is not possible, you check the rays. Okay, if the real reflected rays are intersecting, remember when we define the real image? When the real reflected rays are intersecting, the image form will be real. So for sure, we know it's real and inverted. Then the next point that we need to mention about the characteristics of the image is the size. In this case, this image is a point. All right? And even in this case, it is very tiny. So when the image is very small, extremely small, almost a point, technically we say it's highly diminished. Okay, which means it's extremely small, highly diminished. And please children, please learn the spelling. I don't want demons, okay, because many times children are giving me the spelling of demons here. Diminished, okay, which means extremely small. 2, second position. when the object is beyond the center of curvature. What do we mean beyond center of curvature? It means here is center of curvature, here is the focus, right? It's here. To the left of the center of curvature, we say it is beyond the center of curvature. So here is an object. This is an object. Okay, so we take, here it's possible to take through center of curvature. Please choose that. All right, so here we have a ray passing through center of curvature. It is reflected back along the same path. So this is the incident ray and this is the reflected ray as well. Then the next, second convenient ray, a ray incident parallel to the principal axis. After reflection, it will pass through focus. All right. So this point of intersection now, if we drop a perpendicular from the principal axis, we get the image. Clearly, we see this image is inverted with respect to the object. So it is a real image. Okay. Now we will see the characteristics on those 3 points. First one, position of the image. Where is the image formed? The image comes between C and F. Okay. What is C? C is center of curvature. What is F? F is focus. So it comes between C and F. Don't write near to F or near to C. Just write between. Okay. Then nature, real and inverted. Please don't write only real. Write real and inverted. Okay. Then the size. Look at the size. You can make out it is smaller than the object. So write smaller than object. The third, position of object. When the object is at the center of curvature C. So we have an object here. Okay. This is the object. Now, if it is not possible, because when object is at C, you cannot take the first convenient ray. So you have to choose the other two. Okay. So we choose a ray parallel to the principal axis. After reflection will pass through focus. All right. Then the next ray will be ray passing through focus as an incident ray. After reflection, it will be parallel to the principal axis. So look at, here is the image now. Okay. Now, position of the image, where it is. At the center of curvature, it is formed here itself. So image is at the center of curvature. Then nature, it's real and inverted. Look, you can make out here. It is inverted, so it's real and inverted. Size, same size as the object. Same size as the object. May I remark something here, children? Please remember this. It's only when the object is at the center of curvature that you get the image also to be at the center of curvature. No other positions. So you get same distance of object, same distance of image, same size object and image. This is the only position that you get, where you get object and image to be formed at the same distance from the mirror. This is the only position also where object and image will be of the same size. No other position of object. Then 4. When the object is between center of curvature C and focus F. Remember here we are talking about the object. It's the object here that comes between C and F, not the image. Okay. So here is C, here is F. So we take the object. Here is the object between C and F. Okay. Now in this case, we will take a ray parallel to the principal axis. After reflection will pass through focus. Then a ray which passes through focus as an incident ray. After reflection, it will become parallel to the to the principal axis. We get the point of intersection here at this point, so we drop a perpendicular. Now clearly you can see that object and image are inverted. So this is the image that we get. It's inverted with respect to the object. So now we will see the characteristics of the image. Position of the image beyond center of curvature. Do you see this is beyond? Beyond center of curvature. It is real and inverted in nature, and by looking from here you can make out the image is bigger than the object. The next position of object is when the object is at the focus. So now we are bringing the object straight away at focus. Okay? When object is at focus, now it's possible to take from the tip of this object a ray passing through center of curvature. So here is the ray. So it is incident and then reflected along the same path. Then next we take a ray which is parallel to the principal axis. After reflection will pass through focus. But if you look carefully now, we are getting reflected rays which are parallel to each other. When reflected rays are parallel to each other, we expect them to meet at infinity. So the position of the image will be at infinity. But the real rays are reflected. The real rays are going as reflected rays. So definitely the image which will be formed will be a real image, though we cannot see it. And image which will be formed at infinity will be highly magnified. That means it will become much, much bigger than the object. Okay? Next, when the object is between the focus F and the pole. So here is focus, here is the pole. Now we are taking the object in between focus and the pole. Okay? Here. Taking the two convenient rays, one will be the ray passing through center of curvature. Remember to take it from the tip of the object. Then this ray will be reflected along the same path. Then we take a ray parallel to the principal axis. After reflection, it will pass through focus. You will find these two reflected rays, they form diverging rays. Diverging rays, as you produce them more and more, their distance between them will become more and more. So you can never expect the rays which are diverging to meet one another or to intersect one another. As a result, we cannot expect to see the formation of image by producing the real reflected rays. So what do? Because we have divergent reflected rays, we produce them backwards by dotted line. Okay, produce backwards till they meet. At the point of intersection, then you drop a perpendicular. Remember, we are taking the rays from the tip, so tip will be here. So if you look now, you get object is upright, image is also upright. And we produce dotted lines here, meaning we simply produce the rays backwards for the sake of getting a point of intersection. They are not real rays anymore that we produce backwards. Okay? So let's go and try to interpret about the image. Where is the position of the image? Image now is behind the mirror. You know, images which are formed behind the mirror, they are always virtual image. And another one, clearly we see, now it is erect, that means upright as the object. Meaning, this one is a virtual and erect image. Okay? It's virtual and erect image. And by looking from here, you will see that the size is much bigger than the object. Okay, so we have 6 different positions of object that we learn, and we see that in the 6 different positions we get different types of images. Starting from infinity, we come closer, closer, closer to the mirror till we come very close to the pole of the mirror, and we find we have different characteristics of images. So these are the ray diagrams that we can get by using a concave mirror. Please practice each one of them. All right, because I'm giving in the assignments that you should be drawing them. Practice them at home, not just copying, because they are important for exam point of view. Images formed by a convex mirror. Okay, for a convex mirror, we will do only 2. Number 1, when the object is at infinity. So here you can see we have incident rays to be parallel. Remember, when the object is at a very large distance, we take the incident rays to be parallel to each other. So here we have parallel rays, parallel to the principal axis. And this is the case of a convex mirror, where we silver from the hollow surface and reflection is on the bulging surface. Okay, all right, remember these are rays which are incident parallel to the principal axis. So after reflection, these rays will appear to come from focus, right? Will appear to come from focus. So when you have to draw, you do it like this. You keep your scale at the tip of this incident ray, all right? Then the ray which is reflected from the reflecting surface will be with full line, and then backwards will be by dotted line. So each one of them will appear to come from focus. All right. So where do we get the image? Image is formed at focus. Look at this, at focus. And we simply produce the rays backwards. All right. They are not real rays anymore. Reflected ray is here, reflected ray is here, reflected ray is here, reflected ray is here. So we simply produce them. So it will be a virtual image which will be formed. And this image is almost a point. So it will be highly diminished. Okay. Then next, when the object is between infinity and the pole, right? Between infinity and the pole. So we are not going to take different positions, because all types of images, all types of positions, will form the same kind of image. So we don't have to draw so many like what we did in the case of a concave mirror. Okay, so what happened here? We take the object anywhere between infinity and the pole. By taking those 2 rays, one ray which appear to pass through C, all right, this ray is incident and then reflected along the same path, so we don't have to draw 2, 3. A ray incident parallel to the principal axis after reflection will appear to come from F, so we get a point of intersection here, right? Point of intersection. And remember, this image is formed behind the mirror as well. So this image is formed by producing the rays backwards. As a result, it's not a real image. Okay, so we get characteristics of image: position between pole and focus. Look, where is pole here? This is focus. So always, whatever position of objects you take, image will be between pole and focus. That's why we don't have to draw many. Okay, it is a virtual and erect image. Okay, and always smaller than object. Always smaller than object. Okay, please remember, these are the characteristics of the image that will be formed by a convex mirror. for any position except at infinity. For any position of object between infinity and focus, you will be getting the same type. Okay, so we get the general characteristics of all the images formed. Okay, regarding the uses, please learn them from the textbook. I am not going to write anymore because the points are given clearly in your textbook, but I want you to learn all the details. There are 5 uses of a concave mirror. Let's go to the uses of concave mirror. Number 1, as a shaving mirror. In order to use a concave mirror as a shaving mirror, we will make use the knowledge that when we keep the object between focus and the pole, we get a virtual image which is magnified or which is bigger than the object. And that is very convenient to be used. Why? Because in that case, a person can sit very near to the mirror to make sure that he comes between the focus and the pole, sit near the mirror, and then he will get a magnified image of his face. So he can see the details of his face. That is what he needs, a person's need in order to use it as a shaving mirror. Then point number 2 is as a reflector. Here, as a reflector, it could be in searchlight, in torchlight, and in the headlights of the vehicles. Okay, in order to be used here, the object will always be kept at the object here is the source of light. The source of light means the bulb will be kept at the pole. At the focus. I repeat, the bulb which becomes the source of light will be kept at the focus of the concave mirror. And this concave mirror will be the reflector. Okay? So what happens when you keep the object at the focus? The reflected rays will become parallel, and that is exactly what we need. They will be reflected as parallel rays, and that is exactly what we need in torchlight, in searchlight, as well as the reflector of the vehicles. Then the next is use of concave mirror as doctor's head mirror. Now, in order to get a concave mirror to be used as the doctor's head mirror, the parallel beam from a distant source of light will be made to incident on the mirror kept on his head mirror, the headlight. Okay, he will have the headlight, and a distant source of light will be kept, so that parallel beam of light coming from the source, when they strike the reflector, they will be converging towards the focus. All right, and when you get many rays of light to be converging at a point, meaning you'll get a strong beam of light, and that is what a doctors use in order to diagnose the patient. So this can be used as a doctor's head mirror. Then the next is use of concave mirror in a solar cooker. Here also, in the same way, we have the parallel beam of light coming from the sun, okay, to be incident on the mirror which is placed on a cooker. And parallel beam of light that comes from the source will always be converging towards the focus of the mirror. So if you keep a cooker at the focus, sufficient heat will be reflected from this concave mirror, so as to cook something in a solar cooker. Then the next use is use of concave mirror in floodlights as a reflector. All right. In floodlights, the source of light, or that is the bulb, is placed between the pole and the focus. When you keep something at the pole or the focus, then you get a diverging beam of light. Remember, the reflected rays will be divergence, so you get diverging beam of light. Because in the case of floodlights, we need a large covering of the lights, okay, in order to see something. So we need to have divergent reflected rays. So we use this knowledge. Then we go to the uses of convex mirror. Now, convex mirror is used in 3 different ways. Number 1, as a rear view mirror. A rear view mirror is the one that is fitted in cars, all right? It could be in front of the driver's seat, or it could be on the side of the driver's seat. Now, the knowledge that convex mirror forms small images, okay? Look at this, small images which are erect with respect to the object. So what happens? You will find that if you keep a convex mirror in the rear view of a driver, then small images will be seen. So it can cater large distance of the approaching vehicles behind the driver, not just 1 or 2 and then it will cover full mirror. No, small images can be seen for all the vehicles approaching the vehicle which the driver is driving. So that is of great use. Moreover, a convex mirror forms erect image. Okay, forming erect image means you can see the vehicles behind as they are. Otherwise, if you see them upside down, you will not be able to make out properly. All right. Then the next use of a convex mirror is as a reflector in street lamps. Street lamps are the ones that we call in everyday life street lights. Okay. Now in street lamps, what do we need? We don't need details of everything on the street, but what we want is we have to have large distance to be covered by the light so that we can walk easily and safely in the street. Okay, and then we feel safe because the light is there. So we can see here that a convex mirror will form divergent beam of light if you make them to be incident on it. So the reflected rays can cover large distance. All right. So we use this in order to make one lamp to cover large distance till we go to the next lamp. Okay, that is exactly what is needed in the street lamps. So a convex mirror is used for that purpose as a reflector. Then the next use is as a vigilance mirror. A vigilance mirror is a mirror that is used in the shops. Okay, it could be the malls or big shops in order to see the customers coming and going out. Then the convex mirror is fitted in as a reflector. Okay, so you can have large view in the screen of the owner of the shop, so that he can see who is coming and who is going. Okay, so these are the uses. Please learn the uses carefully from your textbook. Thank you, children.